Hello, everyone, and welcome to this Snyk session, How Twilio Scaled Through Dev-First Security and DevSecOps. My name is Simon Maple. I'm the VP of DevRel and Community here at Snyk. And joining me here today is Yash Kosaraju. Yash, how are you doing?
Hey, I'm doing good. How are you, Simon?
Very well, thank you. You're the head of product security at Twilio. Tell us a little bit about what you do.
Cool. So I've been at Twilio close to 3 years now. My team essentially is responsible for all the security activities in the SDLC, ranging from developer secure coding, training, threat modeling, security champions, to all the way running our bug bounty program, doing penetration tests and things like that, and
Awesome.
covering pretty much everything in between with tooling in the in the build pipeline, working with engineers, all of that stuff.
Sounds like you're a busy man. Sounds like it's a busy team. Well, welcome to the session, and we'll get started, and we'll go deeper in a lot of that going forward shortly. So in this session, we're going to have a very, very brief intro into how modern application development has changed DevSecOps and changed the way we think about security of an app. We'll then cover a little bit of background about Twilio and talk about how dev-first security, what dev-first security and DevSecOps means at Twilio, and go into depth on certain things about responsibility, how we educate developers, and how we enable developers through the pipeline. Okay, so let's briefly jump into how applications have changed in the last number of years. Pre-cloud, of course, we looked at developers who were writing their custom code and pulling in a number of open source libraries. That then got dropped, thrown over a wall, if you will, and dropped onto a stack, a platform that was very much handled by the IT and operations team. Today, in a much more cloud-oriented environment, we see developers actually much more responsible for a larger number of things, including parts of the platform that can include your containers, your config, etc. And as developers handle a lot more of these different artifacts and different configuration files, developers need to be more inclined to maintain, more inclined to secure, and certainly have that understanding of what misconfigurations are, as well as how secure their environments are. So, of course, there are a ton of different types of attacks that could be possible at each of these different layers, and as more of the there's more of the groupings here from your cloud services, your containers, etc. As more of that becomes available to the developers need to think much more about the different types of attack, and that does include your config, your unpatched packages in your operating system, ports, which maybe previously developers didn't need to think about. All of these need to be brought to the developers' attention. So there are a number of different ways in which that can be done, different toolings in which that can be achieved. I'm not going to go through all of this in too much depth, but you'll see on this kind of like iceberg picture, as there is typically custom code which developers have traditionally been more focused on. This is just a small piece of the iceberg, whereas realistically under the covers today in modern applications, there's open source code in libraries that we need to think about making sure where our vulnerabilities exist in those open source packages, as well as in containers, the hundreds of packages that we pull in, thinking about what container version we're using, thinking about which packages we're pulling in, and of course the infrastructure that binds all of that together, the code that we use in the config, the scripts, whether it's Terraform, Kubernetes, whatever it is that pulls all of that together. We need to make sure that in this entire software supply chain, we're not just writing and maintaining, but we're securing and being very conscious of where attacks, etc., can come in. So with that, I did promise there only be a few slides. I'm going to jump across over to Yash again, and yeah, let's have a discussion about some of these pieces, and we'll first talk. Why don't we have a little bit of background about Twilio, maybe the journey Twilio has been on, and the changes in the style of application that you're looking to support, Yash, and I'd love to kind of like know who's responsible for those different areas as well.
Cool. So Twilio has a wide variety of services we provide, right? And that kind of trickles down to things that the security and trust team needs to secure and work with engineering. In terms of how it's divided between the teams, so we have multiple sub-security teams. We have product security, cloud security, enterprise security, well management, and so on and so forth. More relevant to this discussion, I guess I'll focus a little more on cloud and product and how they kind of work in this cloud native environment of like Kubernetes, because you could pretty much make an argument Kubernetes is a cloud security responsibility versus it's not, and then where do containers fit in, right? That's been a interesting debate over the last few years. So the way we try to do it at Twilio is everything that's written by our developers is product security, and then once you talk about how that's deployed on the infrastructure, that's cloud security, and that's super high level. So Kubernetes security is something we work together on. Everything that's AWS and cloud security in general, that goes to the CloudSec team. Security stuff relating to the code that's written internally, the applications we build, and containers, and all that portion of it lies within product security.
What are the typical interactions then between the security teams and the dev teams in those instances? So why don't we take something which is much more on the application side of maybe open source libraries or their own code as well. When do the dev where is that line between where dev find things, where the security team come to the devs with issues? How does that work?
The way I like to think about it is we work with the engineering teams to help them write more secure code and build more secure products for Twilio's customers. I don't want to draw a line of like who finds issues. Anyone within Twilio can find an issue, come to us and say, how do we fix this? Like that's probably my dream if like engineering can